Hello everyone! Today we are going to learn how to solve linear equations with unknown on one side. We are going to be using the Smartboard software to do so. This is for ages around 12 to 13 years old. Let us begin by explaining that equations work like scales. They always need to be balanced. So whatever you do on the left-hand side, you need to do to the right-hand side so that we don't have this swinging movement, so we don't have inequalities. We have equalities and therefore we have a balance. Now let's demonstrate this with some real-life examples. If we want to find how many oranges fit in this red box over here, we need to notice the following things. Well, first of all, this is a scale. We notice that this is balanced, it's not tipped over, therefore this whatever is on the left-hand side is equal to whatever is on the right-hand side. So we have two oranges on the left-hand side, an orange on the right-hand side, and a red box. We're trying to find how many oranges correspond to that box so that our scale remains balanced. Now, if I were to do this manually, I would say, okay, if I remove this orange from the left-hand side, I need to remove also an orange from the right-hand side in order to have my scale being balanced. Therefore, we notice that actually this red box corresponds to the weight of one orange. Now, let's see how we can represent this in a slightly more mathematical way. We have two oranges on the left-hand side, an orange on the right-hand side, and a red box on the right-hand side, and equal because our scale is balanced. So we removed an orange from either side and we were left with an orange on the left, which was equivalent to our red box. Let's have another one. Now this becomes slightly more complicated. We have 5 strawberries on the left-hand side of our scale, which is equal to a strawberry on the right-hand side plus the weight of these 2 blue boxes. We know that these are balanced because our scale is straight, it's not tipped. So if I remove a strawberry from either side, we notice that these 2 blue boxes have the same weight as these 4 strawberries. However, we're only interested for one blue box. Therefore, we have to see how we're going to do this. An easy way is to think about if I had 2 friends and I had to share my strawberries equally with them, I would put 1 strawberry in each box and again another one in each box. Therefore, I notice that I actually have 2 strawberries corresponding to each box. So each of my friends would get a box with 2 strawberries in it. So I would be fair. Let's see this in a little bit more of a mathematical way. So I had 5 strawberries on the left-hand side, a strawberry on the right-hand side, plus 2 blue boxes. Now, I removed a strawberry from either side, and I was left with 4 strawberries on the left-hand side and 2 blue boxes on the right-hand side. Remember, this was balanced because my scale was not tipped over. So let's represent this in the following way. I have 4 strawberries and 2 blue boxes, and I had to share it with 2 of my friends, and I had to be fair, so exactly the same number of strawberries had to go in each box. Therefore, I put a strawberry in each box, and then I put another one in each box, and each of my friends now, this is one friend, and this is another friend, and each of my friends got a box with 2 strawberries in it. Therefore, the weight of one box corresponds to the weight of 2 strawberries. Good, so let's move on to a little bit more complicated example. Exactly the same concept applies. So let's see, we're trying to find how many pineapples fit in one black box. let's see, one black box. That's the important thing. Again, I notice I have a green box on either side, so I can remove that. Let's remove that. I also notice I have two red boxes on both sides, so I can remove those as well. Remove one from here, remove one from here, remove one from here, and remove one from here. Remember, we're doing this so that whatever we do on one side, we need to do to the other side in order for our scale to remain balanced. I also notice I have a pineapple on either side, so let's remove a pineapple from either side. Now I'm left with three black boxes on the right hand side corresponding to three pineapples on the left hand side. Again, my scale is balanced, so I need to split this number of pineapples equally between these three boxes, because if I give each box to a friend, they need to have exactly the same number of pineapples in it. So let's see, if I take a pineapple to this guy, a pineapple to this guy, and a pineapple to this guy, everyone will be happy because they get exactly the same number of pineapples, and I am being fair. Therefore, we can end up saying that a box corresponds to the weight of one pineapple. Now let's see this in a bit more of a mathematical way. So that's what we had initially. We had two red boxes, one green, four pineapples on the left hand side, which were equal, remember, because the scale was balanced, to a pineapple on the right hand side plus a green box plus two red boxes plus three black boxes. We removed a green box from either side, we removed two red boxes from either side, and we also removed a pineapple from either side. And then we were left with three pineapples which corresponded exactly to the weight of these three black boxes. So remember, I had to share these pineapples with three of my friends equally, so I did that, and each of my friends now got a box with a pineapple. There we go, a box with a pineapple in it, and all of my friends were happy because I was being fair and they all got exactly the same amount of pineapples. Okay, all this is nice. However, we are going to be changing our fruit into numbers, our boxes into letters, and our scales into equations. Right, the concept remains exactly the same, so let's see what that means. Remember, we had the red box, the green, the blue, the black box. We're going to call them any letter. For example, I can call X, Y, Z, K, any letter. An individual fruit would correspond to any number, 1, 2, 3, 4, any number. So let's go back to the same examples. However, this time, instead of using oranges, I will be using my letters and my numbers, just as we said before. So remember, we had two oranges on the left hand side, an orange over here plus a red box, and we're going to change that into letters and numbers. So I have two oranges, remember, because numbers correspond to individual fruit. However, the box I will represent with a letter because I don't actually know how many fruit are found inside that red box. So remember, whatever I do to one side, I need to do to the other side. So I have this equation, 2 equals 1 plus x. But remember, I removed an orange from either side, so let's subtract 1 from each side. If I do that, I am left with one orange on the left hand side, which corresponds to the weight of my red box, so 1 equals to x. Let's go on to the strawberries example. Remember, this time we have two boxes, but we're still interested in one. We're interested in only one box. So let's see what happens. I'm going to change the strawberries into letters, and I'm going to change the box I will change the strawberries into numbers and the box into a letter. So I had 5 strawberries on the left hand side, one strawberry on the right hand side, and I had 2 blue boxes. I'm corresponding the boxes with the letter K. If I subtract a strawberry now from either side, I will be left with 4 strawberries on the left hand side and just the 2 blue boxes on the right hand side. But remember, I am only interested in finding how many strawberries are found in 1 blue box, not 2 blue boxes. So I need to consider, if I had to split my 4 strawberries equally between 2 friends, how many strawberries would each friend get? So therefore, I'm going to divide by the number of boxes I have. So I'm dividing by 2. And that gives me exactly how many strawberries are found in 1 blue box. So 2 strawberries are found in 1 blue box. 2 equals K, or K equals 2. Remember, the order is not important in this case. Now, let's see our last example with the pineapples. This again looks a little bit tricky, however, it's not difficult. Remember, we're still interested about 1 black box. Remember, we're changing the pineapples, the individual pineapples, into numbers and the individual boxes into letters. Each colored box is given a different letter so that we don't confuse ourselves. So I'm going to call the green box X. There we go, 1 on either side. The red boxes, I will call them Y, 2 on either side. And I'm just going to call the black boxes Z. And the individual pineapples, I will just call them the number 4 and the number 1, because I have 4 individual pineapples on the left hand side and 1 individual pineapple on the right hand side. Remember, I removed a green box from either side. I removed two red boxes from either side, and I also removed a pineapple from either side. And then if I did that, I am left, let me just illustrate this. If I remove an X from either side, if I remove 2 Y's from either side, so 2 red boxes, and if I remove 1 pineapple from either side, this will become a 3. So let's see what happens now. We are left with 3 individual pineapples on the left hand side corresponding to 3 black boxes. But remember, I am interested in finding how many pineapples in 1 black box. Therefore, remember, I'm going to split this equally between 3 of my friends. So each friend should get the same number. Therefore, we are going to divide by the number of boxes I have to see how many pineapples fit inside 1 black box. So 3 divided by 3 gives me 1. 3 divided by 3 gives me 1 Z. The Z in this case, remember, corresponds to 1 black box. This means 1 pineapple is equal to the weight of 1 black box. So, you have learned how to solve linear equations with the unknown on one side. The unknown in this case, we had the letters, we had X, we had Y, we had Z. That's the unknown. Unknown is the letter, basically the box. How many fruit fit inside the box? So, well done to you. Give yourself a big smile there. You're a star. Thank you for watching.